Right, here we go with our problem set. This first problem is similar to one we did in the note. It says select all of the equations that describe each situation and then find the solution. So our first one, Kieran's backpack weighs 3 pounds less than Claire's backpack. Claire's backpack weighs 14 pounds, so we know what Claire's backpack weighs. We know the difference between them is 3 pounds, but what we don't know is how much Kieran's backpack weighs. So this is our unknown, and in these equations, it's being represented by x. So x would, the weight of Kieran's backpack plus 3 be equal to the weight of Claire's backpack? Yeah, because his is 3 pounds less. If you add 3 to it, you get Claire's. So yeah, that's correct. 3 times the weight of Kieran's backpack equals the weight of Claire's backpack. No, not even remotely close. Is the weight of Kieran's backpack equal to the weight of Claire's backpack minus 3? Yeah, his is 3 less than hers, so this is true. And D, is the weight of Kieran's backpack equal to the weight of Claire's backpack divided by 3? No. Okay, so we just want to use one of these equations to help us solve the problem. I'm going to use A. If x plus 3 equals 14, I'm going to subtract 3 from both sides to get x all by itself, and I get x is equal to 11. All right, moving on. Number 2. Each notebook contains 60 sheets of paper. Andre has 5 notebooks. How many sheets of paper do Andre's notebooks contain? So I think they need all together. They already told us that each one contains 60. So, each notebook contains 60 sheets. Andre has 5 notebooks. How many sheets altogether? Is what we're trying to figure out. And so that's our unknown, and then this set of equations that's being represented by y. So, if I take the total number of notebook pages, would that be equal to 60, the number of sheets in a notebook, divided by the number of notebooks? Nah. This would give me an answer of 12, and I know that the total number of pages cannot be equal to 12, and that just doesn't make sense. In fact, I'm just doing this by myself. If I wanted to, if I've got 5 notebooks, and each contains 60 sheets of paper, I know that I would need to multiply these two numbers to find the total, not divide. So that is not an option. Y, the total number, B, Y, the total number of pages is equal to 5 times 60. Yeah, the number of notebooks times the number of pages in each notebook is giving you the total. So that's good. C, with the total number of pages divided by the number of notebooks, give you the number of pages in each notebook. Yeah, sure would. And lastly, is 5 times the total number of pages equal to 60? No. There's 60 pages in a notebook. I couldn't do 5 times the total number of pages in all the notebooks and end up with the number of pages in just one notebook. All right. So, let's do C to solve it. Y divided by 5 is equal to 60. I don't remember if we looked at one like this when we were solving them. I want to get y all by itself. If it's being divided by 5, I want to multiply by 5. So 5 over 1 times 1 over 5 just leaves me with 1y. And 5 times 60 is 300. And I don't think we looked at something where we had the variable showing it being divided by a number. But you could think of y over 5 as being the same thing as 1/5 times y. And in this case, you would multiply both sides by 5. So it's a little bit trickier. All right. Next page. Where are you? All right. Problem 2. Solve each equation. All right. So, again, I'm going to solve equations by isolating or getting one variable all by itself on one side of the equation. So for A, I have 2 x's, I just want 1, so I'm going to divide both sides by 2. 2 divided by 2 just leaves 1x. And 5 divided by 2 is just 5 halves, which I can convert into a mixed number, 2 and 1 half. Okay. B. 3 1/4 is equal to 1 half plus W. So again, I want to get W all by itself. I've already got just 1. I don't need to multiply or divide it by anything. But I do want to eliminate the 1 half that's on the right side. So I'm going to subtract 1 half from that side. Then I need to subtract, oops, yeah, fudge that up. I want to subtract 1 half from the left side as well. So 1 half minus 1 half on the right side just leaves W. So that's all handy dandy. 3 1/4 minus 1 half. So this might get a little bit trickier. I can't do 1/4 minus 1 half because 1/4 is smaller than 1 half. So what I'm going to do, if you remember from what we did in Delta Math, I'm going to do some borrowing. So I'm going to take the 3 and break it into 2 plus 1 plus 1/4. And I know that 1 is equal to 4/4. So that's going to give me 2 5/4. And 1 half, if I make it into fourths, is going to be 2/4. So I'm doing 2 5/4 minus 2/4. So 5/4 minus 2/4 is 3/4. And then 2, there's nothing to do. So I get 2 and 3/4 is equal to W. All right, C. Y plus 1.8 is equal to 14.7. So the Y, I've already just got one of them, right? So I need to get rid of this 1.8 on the left. So I'm going to subtract 1.8. And I must also do that on the right side of the equal sign. So 1/8 minus 1.8 minus 1.8 is Y. 7 minus 8, I gotta do some borrowing. 17 minus 8 is 9, and 13 minus 1 is 12. So my solution is Y is equal to 12 and 9/10 or 12.9. All right, my last one. 2.5 times T is equal to 10. All right, so I have 2.5 times T. I only want 1 T. So I'm going to divide both sides by 2.5 because 2.5 divided by 2.5 is 1. So 2.5 divided by 2.5 is 1. So I'm just left with P on the left side of the equal sign. And on the right side, 10 divided by 2.5. And this one I can kind of do in my head because if I double 2.5, I get 5. And if I double it again, I get 10. So it will go 4 times. So in that one, T is equal to 4. Oops, not the last one. I misspoke. All right, now E, I have 6 is equal to 1/2 times Z. I want 1Z, not 1/2 Z. So I'm either going to divide both sides by 1/2 or multiply both sides by the reciprocal of 1/2. And that's what I would choose to do. Because the reciprocal of 1/2 is 2. 1/2 times 2 is 1. I should have written this out separately. And then 2 times 6 is 12. So there's my solution. And, you can always go back and check your solutions. If I substitute 12 in for Z, do I get a true statement? Is 6 equal to 1/2 times 12? Yes. So always you can go back and check to see whether you did it correctly by substituting your answer back into the original equation. All right. Problem 3. For each expression, or for each equation, draw a tape diagram that represents the equation. Yay. Okay. So I've got 3x equals 18. So 3 groups of x has a value of 18. That's pretty easy, I think. 3 plus x equals 18. So now I've got a tape diagram that is combining 3 and x and has a value of 18. So also not too tricky. But my last one, 17 minus 6 equals x. So this one, you've got 2 numbers there, so you might be tempted, to want to make a section of tape, two sections of tape and use those two numbers. But it's not showing a combination of those equal to X. It's showing a difference of those two numbers is equal to X. So your tape has to look a little bit different. This is saying that the difference between 17 and 6 is equal to X. So think about that in terms of these. If I wanted to show the difference between 18 and 3, I would subtract 3 from both of these, and that would give me X. I have to think about this one the same way, so I'm going to make my tape diagram. And I know if I have 17 and I take away 6, I'm left with X. So I can think, all right, here's my 6, and there's my X, and there's 17, because this tells me if I combine X and 6, I'll be left with 17. So I have 17 and I take away 6, I'm left with X. So 17 minus 6 equals X. Right. It's a little bit tricky. All right, last page. Find each product. Okay, so this is just straightforward decimal multiplication. So first I'm just going to ignore the decimal points. So I've got 2 times 212. I can put the decimals in there if I want, but when you're multiplying, you do not need to line up decimals. All right, so 2 times 2 is 4, 2 times 1 is 2, 2 times 2 is 4, and I don't even really need to mess around with that. But now, this is not my answer. Now I've got to go back and say, all right, there's 1 decimal point, 2 decimal points, 3 decimal points, or decimal places, I should say. So I'm going to start with my answer and move my decimal point over 1, 2, 3 spaces. So my answer is 0.424. All right, next one, 2.05 times 0.004. So I have 0.004 times 2.05. And again, I don't have to worry about lining decimal points up when I'm multiplying. Now, I put my 0.004 on the bottom because there's only one non-zero digit number. I really only have to go through one string of multiplication, whereas if I had done 2.05 times 4, I would end up like with my 3 rows. I get the same answer, but this is more efficient. 4 times 5 is 20, carry the 2. 4 times 0 is 0, plus 2 is 2. 4 times 2 is 8. And that's it, because I don't have to go through the motions of multiplying by 0. Now, I want to count up my decimal places. There's 1, 2, 3, 4, 5. So even though it seems crazy, starting here, at the rightmost, after the rightmost digit, I've got to move my decimal over 5 spaces. So 1, 2, 3, 4, 5. And that's where my decimal place goes. So 0.00820. Let's see, tenths, hundredths, thousandths, 10,000, 100,000. So this, if I were to read it properly, would be 828 100,000. Okay. All right, last one. From Unit 3, Lesson 13. For a science experiment, it's on here. For a science experiment, students need to find 25% of 60 grams. Data says, I can find this by calculating 1/4 of 60. Andre says 25% of 60 means 25 hundredths times 60. Lynn says both of their methods work. Do you agree with Lynn? Explain your reasoning. Well, when we were talking about benchmark percentages, we did determine that 25% is equivalent to 1/4. So 1/4 of 60 is going to be 25% of 60. And Andre says 25% of 60 means 25 times 60. Well, yeah, that's correct. 25%. 25% is literally 2500. So that is going to be equal to, if I multiply that times 60, it is equal to 25% of 60. So, do you agree with Lynn? Yes. I agree with Lynn. Okay. Here we go.